My dear students, in the previous video, we discussed about the trigonometric ratios in all the four quadrants. In all the four quadrants, what are all the trigonometric ratios are explained? How we explained 90 minus theta, 90 plus theta, 180 minus and 180 plus theta, 270 minus and 270 plus and so on like that. In all the four quadrants, we have found the trigonometric ratios in the previous video. Now in this video, on 360 plus, finally we conclude that in the previous video, the trigonometric ratios are 360 plus theta. 360 means one complete round plus. 360 minus is fourth quadrant. 360 plus is in the, again one round completed, one cycle completed, and plus 360 plus is, it's again in the first or second order it may be. It is one round completed. That is called, this is unit circle, so one complete round is 2 pi. The circumference of the circle is 2 pi, since it is radius is 1. So 2 pi plus theta is our next ratio. 360 plus is otherwise called 2 pi plus theta. See, 2 pi plus is again, we consider it as 360. 360 degree will not alter the ratios. Therefore, 360 plus theta, sin 360 plus is 2 pi plus theta. This is sin theta. Cos 2 pi plus theta, cos theta. Tan 2 pi plus theta, tan theta. Cosecant 2 pi plus theta, cosecant theta, like that. 2 pi plus is also same as 360 plus only. Similarly, if you increase the number of rotations, one rotation is 2 pi, two rotations is 4 pi, three rotations is 6 pi, because pi is 180, one rotation 2 pi, 360, two rotations 4 pi. What is that? 720. Like that, the number of rotations are increased. That's why I am considering trigonometric ratios of 2n pi plus theta. Next idea is 2n pi plus theta. N is number of rotations. N is number of rotations. It is 1 to n, maximum. N is 1 rotation. N is 2. It implies 4 pi, that is 2 rotations. If n equal to 3, 6 pi, that is 3 rotations. If n equal to 4, 4 to 8 pi, that is 4 rotations, like that. So in this case also, 2 pi n plus theta and 2n pi plus theta are all same. That is sin 2n pi plus theta. Similarly, the same expressions we have. Sin 2n pi plus theta. Sin 2n pi plus theta is sin theta. Cos 2n pi plus theta is cos theta. Tan 2n pi plus theta. Number of rotations n indicates the number of rotations. And cosecant 2n pi plus theta is cosecant theta. Secant 2n pi plus theta is secant theta. Cot 2n pi plus theta is also cot theta. Like that, the number of rotations, if you increase the number of rotations, it's again in the existing in the first quadrant, and the same ratios are expressed like this only. Next, I am going to find out the trigonometric ratios of various angles. Now I am going to find out the trigonometric ratios for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Trigonometric ratios for various angles, I mean. Trigonometric ratios of various angles. Trigonometric ratios of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Like that, we have to find out how to find out the various values, trigonometric ratios for these degrees. For that, you remember how to find out the trigonometric ratios for these various angles. You just write 0, 1, 2, 3, 4. You just write out the, see, I am giving you the shortcut method to find out the various angles. Just for that you write 0 to 4 numbers, you write 0 to 4. And you divide each number by 4. 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4. You first write out the numbers. You just write out the numbers 0 to 4. 0, 1, 2, 3, 4 you write. You first write out the numbers 0 to 4 and divide each number by 4. 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4 and so on. Like that. 0 by 4 is 0, you know. 1 by 4 is 1 by 4 only. 2 by 4 is 1 by 2. 3 by 4 is 3 by 4 itself and 4 by 4 is 1. In this stage, you take down the square root for each number. Taking the square root for each number, 0. Square root of 0 is 0. Square root of 1 by 4 is 1 by 2. Square root of 1 is 1, 4. Square root of 4 is 2, 1 by 2. Square root of 1 by 2 is 1 by root 2. And this is root 3 by 2. Taking square root on the numerator 1, denominator root 2. Similarly, numerator root 3 by square root of 4 is 2, square root of 1 is 1. So first you write 0, 1, 2, 3, 4 numbers and you divide each number by 4. I get 0, 1 by 4, 2, 1 by 2, 3 by 4 and 4, 1. Taking square root for each number, I will get square root of 0 is 0, this is 1 by 2, this is 1 by root 2, this is root 3 by 2 and this root of square root of 1 is 1. This is nothing but the values of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree for sine values, for sine theta. Sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. Like that. You just write out the numbers from 0 to 4 and divide it by 4 and taking square root, you will get the values of sine. It is, if you, since cos theta is complement of sine, since cos theta is the complement of sine theta, you will just reverse the value. Cos, rewrite the value from 90. Because sine 0 is 0 but cos 90 is 1. So, sine 0, already you reverse the value, sine 0 0, sine, cos 0 1. You write the values in reverse order, root 3 by 2, 1 by root 2, 1 by 2 and 0. So sine 0 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 1. Whereas cos theta, cos 0 1, reverse order, cos 30 1 by root 3 by 2, cos 45 and sine 45 are one and the same. Cos 60 1 by 2 and cos 90 0. Sin 0 and cos 90 0. Sin 30 and cos 60 1 by 2. Sin 45 and cos 45 1 by root 2. Sin 60 and cos 30 is root 3 by 2. Like that. Immediately we can find sin cos using this method. And straight away we can find out tan. Because sin theta by cos theta is tan theta, you divide each and every term by 1 by 1, we will get sin theta, tan theta is sin theta by cos theta. Sin theta is by cos theta is tan theta, so 0 by 1 is 0. 1 by 2, root 3 by 2 is 1 by root 3. 1 by 2, 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 by 1 by 2 is root 3. 1 by 0 is infinity. So tan 0 0. Tan 31 by root 3, tan 45 1, tan 60 root 3, tan 90. And you rewrite the reverse in cos values, you write the value in the reverse order. Cos 0 infinity, cos 30 root 3, cot 0 infinity, cot 30 root 3, cot 45 1, cot 60 1 by root 3 and cot 90 0. Similarly, reverse order, tan and cot are reversed. And cosecant, you can say immediately, cosecant is reciprocal of sine. Sine 0, 1 by, cosecant 0 is 1 by 0. Cosecant 30 is sine 1 by sine 30, that is 2. This is cos 45, say cosecant 45 is reciprocal of cos 45, that is root 2, 1 by root 2 is root 2. And this is 2 by root 3, because cosecant 60 is 2 by root 3, reciprocal of sin 60. And 1 by 1 is 1. Reciprocal of 1 is 1. Cosecant 90 is 1 by sin 90, that is 1. Similarly, secant theta is again reciprocal of cos 1 by 1, 1. Cosecant 30, 2 by root 3. Secant 30 is 2 by root 3. Secant 45, reciprocal of cos 45 root 2. This is 2 and secant here 90 is infinity. Like that, we completed the values. Similarly 180 and this value cos sin 180 is again sin 0 and cos 180 are same. Like that, you have to find out the values of 180 degree, 270 degree and so on. Now, this is the shortcut method of finding the values of 0 to 90 degree of all the trigonometric ratios. Just to write the numbers from 0 to 4, divide by each number by 4 and taking the square root, you just write the values for sine and reverse order you will put cos, sine by cos is tan and reverse of tan is cot, reciprocal of sine is cosecant and reciprocal of cos is secant, that's all. So using these ideas, we are going to solve some problems in the exercise now. Exercise 3.2. Problem number 1. If cos x equal to minus 1 by 2, cos x equal to minus 1 by 2 where x lies in third quadrant, where x lies in the third quadrant, where x lies in the third quadrant. Find out the remaining 5 trigonometric ratios. Cos x is minus 1 by 2 given. From this, you know, the sin square x plus cos square x is 1. From this, sin square x is 1 minus cos square x. That is equal to 1 minus cos square x is minus 1 by 2 square, because cos x is minus 1 by 2. On squaring you will get 1 minus 1 by 4, that is equal to 4 minus 1 by 4 into 1, 4 minus 1 is 3 by 4. This is sin square x. From this sin x is plus or minus 3 by root 3 by 4 is plus or minus root 3 by 2. Taking square root in the numerator, you will get root 3, square root of 4 is 2, therefore sin x is plus or minus root 2, root 3 by 2. Since x lies in the third quadrant sin is negative, therefore sin x is minus root 3 by 2. Out of these two values, plus root 3 by 2 we have to omit. We have to eliminate plus root 3 by 2 because x is in the third quadrant. In the third quadrant sin is negative, therefore minus root 3 by 2 is your answer for this problem. So sin and cos we have determined. Now it is tan. I can already told you tan x is what? Tan x is sin x by cos x. What is sin x? Minus root 3 by 2. Cos x is minus 1 by 2. Dividing 2 by 2. Cancel root 3 by minus minus plus, you will get root 3 only. Tan x is root 3. Reciprocal of tan is cot x. So cot x is 1 by root 3. Similarly, cosecant x, reciprocal of sin x. Tan and cot are positive in the third quadrant. Therefore, I am writing positive values. Tan and cot are positive in the third quadrant. Therefore, third quadrant tan and cot are positive. Cosecant is negative. Reciprocal of sine minus 2 by root 3. Similarly, secant is also in the negative in the second quadrant, third quadrant. Reciprocal of cos minus 2. Cosecant is minus 2 by root 3. Secant is minus 2. Cot root 3 tan 1 by root 3. Like that, we have determined all the remaining 5 ratios using the given cos x is minus 1 by 2. One more problem in your exercise. One more problem in the exercise. Fifth problem is tan x equal to minus 5 by 12. Fifth problem, if tan x equal to minus 5 by 12, x is in the second quadrant. X is in the second quadrant. Second quadrant, sine and cosecant only positive, tan negative. From this, we can immediately say cot x. We can find out cot x, reciprocal of tan x is minus 12 by 5. Tan x minus 5 by 12. Cot x is minus 12 by 5 because in the second quadrant, cot is also negative. The second quadrant, what are the ratios positive? In the second quadrant, sine and cosecant are positive. Therefore, cot x is also negative. Reciprocal of tan cot minus 12 by 5. You know secant square x by trigonometric identity. Secant square x is equal to 1 plus tan square x. 1 plus tan square x is equal to secant square x. Trigonometric identity, that is equal to 1 plus tan x is minus 5 by 12 square. Tan square is minus 5 by 12 the whole square. That is 1 plus 25. 5 square by 12 square is 144. So 144 plus 25 is 169 by 144. Therefore, secant square x is plus or minus root of 169 is 13 and 144 is 12. Since the second quadrant tan is negative, your answer for secant x is minus 13 by 12. This is your secant. Minus 13 by 12. From this, cos reciprocal of secant minus 12 by 13, because cos is also negative in the second quadrant. Now we have to find out tan x. Tan x equal to, we have to find out sin x. Tan, cot, cosecant, cos, secant we have determined. Finally sin x. Sin x is, from my trigonometry, tan x into cos x is sin x. Because tan x is sin by cos, cos cancel, you will get sin x. The expression for sin x is tan x into cos x. Tan you can write it as sin by cos. Tan sin x by cos x into cos x. Cos x cancel, will get sin x. Therefore, sin x is tan x into cos x. What is tan x? Minus 5 by 12. And what is cos x? Tan x is minus cos x minus 12 by 13. That is minus into minus plus. 12 to are cancel. 12 cancel, minus and minus plus 5 by 13. Sin x is positive in the second quadrant, therefore we will get 5 by 13 in positive. So we get cos, cot, tan, cot, secant, cos, sin also we have determined. Next, cosecant. Reciprocal of sin is 13 by 5. So all the 6 ratios we have determined from this problem. That's all about the problem. And I will stop this video here. In the next video, I will continue the remaining problems in the exercise. Thank you.